Imagine this, a single, tiny decision, like choosing to walk instead of drive, sets off a chain of events that changes the course of history. Now take it a step further. What if our universe is a simulation, where every tiny action creates ripples in the code? Could the flap of a butterfly's wings in a simulated forest ultimately alter the trajectory of entire civilizations? This is the butterfly effect, the idea that small changes can have massive consequences. But in a simulated universe, these ripples might not just affect the simulated world, they could be intentional. What if the creators of the simulation designed this world to magnify small choices? Are we part of an experiment where every action, no matter how insignificant, is calculated for its cascading impacts? Today, we're diving into the butterfly effect within the context of a simulated universe. How do tiny changes matter in a world governed by algorithms and rules? The butterfly effect, a concept rooted in chaos theory, suggests that minor changes in initial conditions can lead to vastly different outcomes. Edward Lorenz, a meteorologist, coined the term while studying weather systems. He found that rounding a single decimal point in his equations caused wildly different predictions. The metaphor of a butterfly flapping its wings and influencing a distant tornado perfectly illustrates the concept. Now, let's connect this to the simulation hypothesis. The idea that our universe might be an artificial construct created and governed by an advanced intelligence. In such a universe, every detail, from the orbits of planets to the thoughts in your head, could be encoded in a complex system. And within this system, the butterfly effect might not just be a natural phenomenon, it could be a deliberate feature. As advancements in AI and computing make simulations more sophisticated, the concept of the butterfly effect takes on new relevance. For instance, when creating video games or AI models, developers program systems where minor player decisions can lead to significant outcomes. What if the same principle applies to our reality? But why would a simulated universe prioritize the butterfly effect? Perhaps it's a tool for studying complexity, or maybe it's a way to teach moral responsibility. Whatever the reason, this concept forces us to reconsider the importance of small actions in a potentially simulated world. The butterfly effect in a simulated universe raises several intriguing challenges. First, there's the question of determinism. If our universe is governed by algorithms, does that mean every action's outcome is preordained? Or is there room for randomness and free will within the simulation? Another challenge lies in detecting the butterfly effect itself. In a simulation, how would we identify small changes that lead to significant consequences? In the real world, the effects of tiny changes are often subtle and take time to manifest. In a simulated world where the creators might control the flow of time or events, these ripples could be even harder to trace. Then there's the ethical dimension. If the creators of the simulation designed it to amplify small changes, what does that say about their intentions? Are they testing us, observing how we handle responsibility? Or are we part of a chaotic experiment where the consequences of our actions are exaggerated for the sake of study or entertainment? Finally, the butterfly effect challenges our perception of significance. In a simulated world, does every action matter equally, or are some events programmed to be more impactful? If every small action creates ripples, how can we ever predict the outcomes of our decisions? This uncertainty can be both empowering and overwhelming. Understanding these challenges requires us to delve deeper into the mechanics of the butterfly effect and its implications for a simulated universe. Let's unpack the butterfly effect in a simulated universe by examining how it might operate. In a world governed by algorithms, every action, no matter how small, could be tracked and calculated to produce cascading effects. This means that even the tiniest decisions, like the words you choose in a conversation, could influence the larger simulation in unexpected ways. Consider video games like The Sims or Red Dead Redemption 2, where player actions ripple through the game's world. Developers intentionally program systems where small choices, like befriending an NPC or saving a random character, alter the story's trajectory. Could the creators of our simulation use similar logic, amplifying small actions to explore their outcomes on a massive scale? Another fascinating angle is the relationship between chaos and order. In chaos theory, the butterfly effect suggests that small changes lead to unpredictable outcomes. But in a simulation, unpredictability might be an illusion. The creators could control or predict these ripples, subtly guiding the system toward specific goals. This raises the question, are we living in a deterministic simulation where the butterfly effect is a scripted feature? Finally, let's explore evidence. Quantum mechanics, for example, shows that particles behave differently when observed, suggesting a link between observation and reality. Could this phenomenon hint at a programmed reality where every observation, no matter how small, alters the code? Similarly, synchronicities or glitches in our daily lives might be signs of amplified ripples in the simulation. Here's the breakthrough. If the butterfly effect is real in a simulated universe, it redefines how we view free will, responsibility, and reality itself. Small actions become monumental, not just because they ripple through the simulation, but because they might be intentionally magnified by its creators. Imagine a scenario. You choose to help a stranger on the street. In a simulated universe, this minor act of kindness could ripple through the system, altering the stranger's life trajectory and, in turn, influencing countless other lives. Now magnify this process on a global scale. If every action is amplified, then the weight of our choices is far greater than we imagine. This concept challenges the notion of insignificance. In our daily lives, we often dismiss small decisions as trivial. But if the simulation is designed to highlight these ripples, every action could carry profound meaning. This realization can be both empowering and daunting. It suggests that even in a simulated universe, our choices matter deeply. The climax of this discussion lies in the profound implications of such a design. If the creators of the simulation amplified the butterfly effect, it could be a way to test moral responsibility, encourage growth, or even entertain themselves. Alternatively, it might serve as a tool for studying how small changes shape complex systems, providing insights for their own world. To conclude, the butterfly effect in a simulated universe isn't just a theoretical concept. It's a lens through which we can understand the profound impact of small actions. Whether by design or natural occurrence, the ripples of our decisions might shape the very fabric of the simulation. We've explored the roots of the butterfly effect, its challenges, and how it might function within a simulated world. From philosophical questions about free will to scientific theories about quantum mechanics, this topic bridges multiple disciplines. It forces us to reconsider the weight of our choices and the complexity of our reality. Ultimately, the butterfly effect in a simulated universe suggests that every action matters. Whether we're part of an experiment, a story, or something beyond our comprehension, our decisions create ripples that shape the simulation, and perhaps even influence the creators themselves. What do you think? Do you believe the butterfly effect operates in a simulated universe? And if so, how? Are we part of an experiment designed to amplify our choices? Or is this just a natural phenomenon of a complex system? Share your thoughts in the comments below, and let's start a conversation about how small actions can have big consequences. If you enjoyed this video, don't forget to check out our other content exploring the mysteries of simulation theory and chaos. Don't forget to like, subscribe, and hit the bell icon so you never miss a chance to question the nature of reality with us. Thank you for watching.